Okay, Wildcats. Today I'm going to be doing a tutorial video on the my.hrw.com 1.1 domain and range and behavior homework assignment. Now, the screen you're seeing is basically my side of the my.hrw where I create the assignment. But you can see here 1.1, I have the ability to view, so I'm going to go and click that now. Now, I'm not going to go over this specific question. I'm going to click on example, and I'm going to come over here to try another. Okay, so if I explain this one, this should help you with the assignment. Now, I'm going to go through all 15 questions. That's going to make it a little bit of a longer video, but remember, you can always fast forward to get to the question that you had trouble. Okay, but I want to make sure that I cover them all, so that way if you had any questions on any questions, I've helped you on all of them. Okay, all right, so let's look here. It says, select the interval shown in the number line as an inequality using set notation and using interval notation. Okay, so inequality. Okay, so let's look at the answer choices. Okay. Now, here you can see the x in the answer. So the best way I can explain is, let me draw this out, is the inequality almost makes an arrow. Okay, so we know whenever you're doing inequality notation, always put the x on the left. So let's start with x. Okay. Now you can see here that the arrow is pointing to the. Right, I don't know what this is. Let me close it out. Okay. See how it's going to the right? Well, the inequality symbol should align with the arrow. Okay, so we know that now x is greater than, because there's a dot, it's aligning to x is greater than or equal to 1. Okay, so we can look at the answer choice here. All right, so you can see the answer is this. Okay, now set notation is easy once you know inequality notation. Set is the same as inequality except for it includes the x such that. So the answer here is x greater than or equal to 1. Now interval notation, okay, uses brackets and parentheses. Okay, so here, if it's a closed circle, we know it's a bracket. So we have a bracket. We have a bracket here. So bracket, okay, 1, comma, and it's going to positive infinity. Okay, and infinity always has a parenthesis. Okay, so let me grab the mouse here, and so it's hard to see, but there's a bracket there and there's a parenthesis. So 1, 2, and it's positive infinity. I would argue that you don't need to put the plus in front of the infinity, because if you put a negative implies it's not positive. Okay, so I disagree that they have to put a plus sign, but it is what it is. Okay. All right, let me see if I can press that. It says Alt E, so let me find my Alt button. Alt E. Oh, I thought it would delete everything, so I gotta manually delete this. So give me a few seconds to do that. All right, so we go to the mouse point. Let's go down to check answer, make sure I've explained it correctly to you. I have, so let's move on to number 2. So I'm going to go to example, try another question. Okay, so select interval notation for parentheses 2, comma 100 bracket. Okay, as an inequality using set notation. Okay, so let's look at the answer choices. So they're using basically the inequality symbols next. So the best way to explain this is whenever you're doing that, it's obviously x is between 2 and 100. So we know x is in the middle. The inequalities, when you're doing this, always face this direction. Okay. Now what that's saying is that x is greater than 2. Since it's a parentheses, there's no line underneath, it's not including 2. But x is less than 100, but it includes 100 because it's a bracket. So there's a line underneath. Okay? So the answer choice is, be careful, that doesn't have a line underneath there, so the answer is here. Okay, now let's look at set notation. Basically, it's the same thing except for that it says x such that. And let's check the answer. It is correct. Delete that. And let's move on to question number 3. Okay, so I'm going to go to example, try another. All right, select the interval notation using at notation. Okay, so here, basically that line underneath, so it's bracket, no line underneath parentheses. So Oh, I'm sorry. This is actually easier than I thought. Interval notation is the same as set notation, so it's x such that. So basically, this is the same as set notation. So, there it is. All right, now interval notation, that's where you get into the bracket and parentheses. So bracket, parentheses, and it's between. So we know it's bracket, -16, and that's incorrect because that's a bracket. That should be a parentheses because there's no line in these, so the answer is here. All right, so now let's check the answer. It is correct. So let's look at example number 4. Okay, so I'm going to click on example, try another. All right, select the interval notation as an inequality using interval notation. So let's look at inequality. Okay, so interval and inequality notation are basically in essence the same thing, except for interval has x such that. So basically this and inequality are the same thing. So look for the identical. So -2. All right, they're the same. That is correct. All right, interval notation. Okay, now no line needs parentheses, no line needs parentheses. So there should be parentheses, -2, comma 9. Okay, that's how simple that is. No line needs parentheses, no line needs parentheses, and it's between. Okay, so then let's check answer. That is correct. All right, let's move on to number 5. All right, select the, oh, wait, I'm sorry. Let me click on example. Try another. All right, select the domain and the range of the function as inequality notation using set notation and using interval notation. Also select the end behavior of the function or complete the explanation of why there's no end behavior. Okay, so domain. And I don't know where that came from. Let me delete that. All right. So let's look at the answer choices. All right. So basically, domain here is it's infinite. It's going in the infinite direction, the negative direction. It's going infinite in the positive direction. So it's basically from negative infinity to positive infinity. So the answer is, now be careful. You never write the inequalities in this direction. They're always in this direction. Okay? Because x is always greater than the negatives, but less than the positive infinity. Okay? All right. Inequality and set are the same thing. So once you have that, these are identical. Interval notation, again, is just the same thing, just using parentheses, negative infinity to positive infinity. Now range, here, and I don't know what's going on with there, but range is from bottom to top. So the range starts at 4 and it goes to infinity. Okay? So let's look at the answer choices. Inequality. Now, I would argue that I'll show you the correct answer, but I think that there's a problem with the answer. The answer is this, but I would argue that, a pin here, that you don't have to write the positive infinity there. You could just write it as 4 less than or equal to y. And the reason being is, if I rewrite this, I can write it as y greater than or equal to 4. This implies the positive infinity. By the way, these are the same thing. If you were to flip your computer over, you would see that this would become this and this would become that. Okay, so that's the correct answer. I would just disagree that you have to put the infinity aspect because that implies it's y is greater than or equal to 4. That implies going to infinity. All right. Now, set notation, once you have this, it's the same thing. So, all right, now interval notation is basically, so there's a line, so we know it's bracket. So it's bracket 4, because you're starting at 4, and it's including 4, and you're going to infinity. Okay, so the answer is, so bracket 4 to infinity. All right, and let me delete or erase all this. There's a big eraser, but it is what it is. Try to be fast. All right, now let's check the answer. Oh, almost, wait. Oh, I got more to delete. This is probably going to drive you crazy, probably going to drive me crazy, all this blue stuff to erase, but we'll get through it. Now, in behavior, okay? So basically, and I'll just draw sketch here down here, okay? Now, it says as x approaches negative infinity. So as it goes this direction, okay, it's going up, okay? That's your negative, okay? And as it's going this direction, positive is going up. So basically, when you go left negative, right positive, it's going to go basically up positive, okay? I know they're writing the arrow this way. So really, I'm drawing that to, that's what this is saying. It's saying it's going to the negative. It's just odd that way, okay? But anyways, so it's going to positive infinity when you go left and positive infinity when you go right, all right? And let me erase this. And let me check the answer. Correct. All right. So now let's take a look at question number 6. All right. Select the domain and range of the function as inequality using set notation using interval notation. Also select the end behavior of the function or complete the explanation why there's no end behavior. Okay. All right. Domain. So here it's going infinite direction left and it's going infinite direction on the right. So there's no stopping point left or right. So domain is from negative infinity to positive infinity. Now they're trying to trick you. You never include infinity. Infinity can never be included because it's infinitely. Okay, so be careful on that. All right. Set notation is the same. All right. Now interval notation is basically just from negative infinity, positive infinity. You never include brackets when you're talking about it because that saying it stops at infinity. Infinity never stops, so it's there. Okay. And weird how that stuff just shows up in the most random places. Let me see if I just erase everything in the back. Maybe that will get rid of it. All right. So now let's look at range. Now range, that line looks like it's included, but it's not. Okay. So the range is, it's really going to drive me crazy that they're using this notation, but it's greater than 0 and going to infinity. And again, I would argue that that's poorly written. This should be written as y greater than 0. Okay. That is just, whoever wrote this was, I would argue, I don't know what they're talking about. That's poor notation. It might be mathematically correct, but it's poorly written. I would argue that you should write it that way. All right, set notation is the same thing though. So let's see. All right, now interval notation is basically, it's not including 0 and it's going to infinity. Be careful to never put a bracket with infinity, so it's there. All right, now end behavior. So as we're going this direction, I'm sorry, as we go in a positive direction, okay, so as x approaches this way, we're going up, so positive infinity. Now as x is going this direction, see this one is approaching 0. And don't stress too much. We're going to continue to go over end behavior. End behavior takes a while to really process and understand, okay? So let's check to make sure it's correct. It is. All right, so now let's go to question number 7. All right. Select the domain and range. Oh, wait, I'm sorry. Let me go to example. Try another. All right. Select the domain and range of the function as inequality using set notation and using interval notation. Also select the end behavior of the function or complete the explanation why there is no end behavior. Okay. The graph of the linear function. Now, domain and range for linear function is always negative infinity to positive infinity for both domain and range. Okay. It's never using the line underneath. So it's here. And remember, inequality and set are the same thing, except for that includes x such that. And then interval notation is basically negative infinity, positive infinity. It's always parentheses, never brackets. And again, domain and range is the same. There is no stopping point. All right? And behavior. So as x approaches negative infinity, it's going down, so it's approaching negative infinity. As x approaches positive infinity, it's going up to positive infinity. Let's check the answer. That's correct. All right, let's go to question number 8. We go to example. Try another. All right. Select the domain and range of the function as an inequality using set notation and using interval notation. Also select the end behavior of the function or complete the explanation of why there is no end behavior. Okay, let's go through here. Now domain is including -4 to 4. Okay, so those are going to be lines underneath for both. Okay, so it's, and it never, this is the, you want to make sure this is never correct. It's always this direction. And so it's from x is between -4 and 4 and including -4 and 4. Set notation is the same thing. All right, interval notation, it doesn't have a dot, but it doesn't have an open circle, so we assume it's bracket. So bracket -4 to 4. Now range is bottom to top, so you can see it starts at 0, including 0, and it goes to 4. Okay, so the range, again, this is never correct, it's always this, so it's 0 to 4. Okay, so from 0 to 4, including 0 and 4, same thing. And then interval notation, again, it's bracket for both between 0 and 4. 0 and 4. All right, let's check the answer. Oh, try again. I apologize. I forgot to answer the end behavior, so let's answer that now. There's no end behavior because the domain is bounded. So let's look at the answer tab. Okay. There is no end because the domain is bounded. All right. Neither end, there is an end. I would argue there's both ends. So x cannot increase or decrease without bound. Correct. All right. So now let's go to question number 9. And go to example. We go to try another. All right. For the given function and domain, select the graph and identify the range using the same notation as the given domain. So as f of x equals -x plus 3 with domain -10 to 8. So what we have to do here is we have to plug in domain is the x value. So we're going to plug in -10 in for x, and that will give us our range value. And we'll do the same thing for 8. Okay. All right. So let me grab my stylus. So basically, that would be f of -10, because the x value is -10, equals negative parentheses -10 plus 3 equals. Okay, so a negative times negative is a positive, so it's positive 10 plus 3 is 13. So your range value is 13. Okay, so now let's do f of 8. So that equals negative, let's use 8, you're plugging in 8 for x, because x is the domain, plus 3. So that's -8 plus 3, which equals -5. So domain is from -10 to 8. So let's look at the answer choices there. Okay, so let's see. Oh, I'm using the wrong scroll down. All right, so this looks like -10 would lie there. So -10 to 8. So you're okay there. Now, that is wrong in that it's included in, there's no, not included. So all the answers with open circles are incorrect. There's nothing prohibiting a point. So by that, we're narrowed down to 8, but let's double check that we're at -5 to 13. -5 looks like it's about -5 would be there and 13 would be there, so the answer is A. All right, let's check the answer. select the range. I'm sorry, the range is from -5. You always do bottom to top. Now it's included in both, so it's bracket -5 to 13. Now let's check. Part 1, I get a check, and part 2, so that's correct. All right, let me erase this stuff. Have to. Hopefully I got it all. All right, so now let's take a look at number 10. All right. All right, so now some of the same concept. Okay, now there's no line, so that means it's not going to include the value when you plug in -8. Okay, so let's grab the stylus. All right, so we're going to do f of -8. So the x value is -8. So plug that in, so that's equal to 7 divided by 4 times 8, or -8, sorry, -8 plus 4. All right. So what you're going to do here is -8 divided by 4 is -2. -2 times 7 is -14. So that's -14 plus 4. And that equals, I guess I can write over here. Oh, whoa, I lost the screen. I guess I can't do that. Let me go back. Lost it there. Equals -10. I thought I could use the space. I lost it again. No. I did. Equals -10. Lesson learned. But wait. Ha. Now I have the screen. Now I can write the -10 there for 1. All right. So we know the domain starts at -8. Okay. So let's look at -8. So that looks like we're okay. Now we know it's open circle, so it can't be the closed circle. So you can eliminate B. And I'm using my stylus. You can eliminate B. And you can eliminate C. And the reason being, those are closed circles, but we have parentheses, so we know it's not included. Okay. Parentheses means open circle. Okay, let me draw that. When you see a parenthesis, no parentheses means open circle. Okay. All right. So now we know that we're starting at -10. So that looks like that could be okay. Let's look at the other answer choice. But here this is starting at -4, but we know it starts at -8. So the answer is A, because it starts at -8 on the X and it starts at -10 on the range. Okay, let's check the answer. Oh, I bet you there is another. No, that's it. So let's check. Oh, now it wants. So the part. Oh, that's correct. Now it says range. So range is it's going from -10 to infinity. So y is greater. Thank you. They finally wrote it correctly. Y is greater than -10. Check. All right, those are correct. Let me erase those. All right, number 11. Let's go to example. And let's. Oh, there we go. Example. Try another. All right. Part 1 out of 2. Enter a function that models a given situation. Select the correct domain from the situation. Use a set notation for the domain. A bicyclist travels at a constant speed of 12 miles per hour for a total of 42 minutes. Okay. A function is d of t equals blank. So 12 miles per hour, that's your rate, and that's the number that's going to go in front of t. So 12 goes there. Okay. Where t is time in hours and d is a distance. Now domain is a bicycle travels at a constant speed of 12 miles per hour for a total of 42 minutes. So the least amount of time is 0. The most would be 42. But I find those that I may be reading that incorrectly. Okay. So give me a second to reevaluate what I'm saying. Is now, and I'm glad this happened. If you get stuck, like I'm kind of stuck on this question, I'm kind of confused. I can actually go to the example and you can actually read through and it's going to walk you through. So I'm actually going to, well, let's just work through this actual problem together. Okay. So it says part 1 and 2. Enter a function that models a given situation. Determine the domain from the situation. Recall that when a real-world situation involves a constant rate of change, a linear function is a reasonable model for the situation. The situation may require restricting the function domain. The bicycle's speed is 12 miles per hour. The distance traveled d in miles at any time t in hours is modeled by d of t equals 12t, like I was saying here. But this is where I had some trouble. Since the bicycle's travel is 42 minutes, so 42 minutes is 0.7 hours. So basically, if you were to put we know there's 42 minutes, and there's 60 minutes an hour. So if you do 42 divided by 60, I believe, I'm almost certain I will give you the 0.7. Okay. The domain is restricted to the interval 0 to 0.7. So what they're saying, and this is where they got the 0.7, 42 divided by 60, because there's 60 minutes an hour. So give me a second. Let me use my trusty phone here that has a calculator to double check that. I don't know if you're able to find your calculator quickly on your phone. I never can. 42 divided by 60 is 0.7. So I can't actually show you my phone on the video, I believe. You see to have some sort of restriction on that, but just trust me, if you grab your phone, 42 divided by 60 is 0.7. Okay? All right, now let's continue with the rest of the question. All right, from the graph, you can determine the range is, so basically, we know it's going from 0 to 0.7. So where they got the 0 and 8.4 is they plugged in the 0 and 0.7 into the function. So your function is d of t equals 12t. Well, if you plug in 0, that's simple. d of 0 equals 12 times 0 equals 0. That's where they get the 0. Now they plug in 0.7 for t. So d 0.7 equals 12 times 0.7, and let's check my trusty calculator here on my phone. 12 times 0.7 is, wouldn't you know it, 8.4. Okay, well, that's a terrible 4. There you go. All right, and I believe that's, I don't think we need to go back and actually type the answers in to check. That should explain that question. But again, when I'm not available or you don't really want to watch the video with me the whole time, what I recommend is they have great explanations on the problems that you can use and read. And that's what I would do if I got stuck on a question. Okay, I would go through and read what they have an example. Okay, but let's look at number 12. All right, and an example, let's go to try another. All right, enter a function that models the given situation. Determine a domain for the situation using inequality for the domain. An elevator in a tall building starts at a floor of the building that is 116 meters above the ground. The elevator descends 3 meters every 0.5 seconds for 10 seconds. Okay, so it says an elevator in a tall building starts at a floor of building that is 116 meters. Now it says t is time in seconds, h is height. So the 116, that's your starting point. Okay, so you start at 116 and you're descending, it says at 3 meters every 0.5 seconds. Now I'm going to say that's 3, but if I'm wrong, I'm going to go to the example and we'll go through and find out. Stay here. Now, and actually, honestly, now that I think about it, I think it's better if we go to read the example and follow the steps, because there's going to be clarification. Because to go from here to here, I think they're going to have a better explanation than I am, and it's much more efficient. So let's look here. Okay, so it's in their function. So I made a mistake. You can see the 6. Let's see where they got the 6 from. Recall that when a real-world situation involves a constant rate of change, a linear function is a reasonable model for the situation. The situation may require restricting the function domain. The elevator rate of motion is -6 meters. Okay, and I think, and let me check something real quick. Yep, what they did was the rate is 3 meters divided by, because it says 3 meters every, so that's the rate. So 3 divided by 0.5. And when you do that, you get, remember it's negative because it's going down, -6. So that's where they get the -6 from. Okay. Now the elevator's height in meters at the time is modeled by 116 minus 6t. Since the elevator descends for 10 seconds, the domain is restricted between 0 and 10. Okay, and I'm hoping I can use space over here. But let me scroll down. Okay, so to find the range at 56 and 116 is you're going to plug in, that's what here. So you're going to plug in the 0 and the 10 into the function. So h of 0, good, I can use the space right here. H of 0 equals 116 minus 6 times 0 equals 116. So that's where they get the 116. And then we're going to plug in 10 in for t. So that's h of t, so h of 10 equals 116 minus 6 times 10. And 116 minus 60 is 56. And then remember range, you go from lowest to highest, and that's why they have 56 to 116. Okay? All right? And let me erase that. All right, and go here. I don't know why that just popped back up with whatever. So let's move on to 13. Okay? Cameron sells tickets at a movie theater on Friday night. She worked from 3 p.m. to 9 p.m. and sold about 45 tickets every hour. Cameron says that the number of tickets and she sold at any time. Sorry, this is. Let me try to get this out of the way. All right. Time t in hours can be modeled by the function n of t equals 45t, where the domain is 0 to 1 and the range is 0 to 45. Is Cameron's function along with the domain and range. Cameron's function along with the domain and range. Correct. So let's see. The correct function. It says it sold 45 tickets every hour. So 45t. I'm going to say that that's correct. Okay. Therefore, Cameron is, let's just say, correct about the function. So I'm saying she's correct. The correct domain is, let's see. And again, when you get to a point like that, I'm going to revert back to here and I'm going to go get their explanation because that's going to be much more efficient to help you with that. Cameron's function is correct, she said. Cameron worked a total of 6 hours. So from 3 to 9 is a total of 6 hours. That's how we get the 6. After 6 hours, Cameron sold a total of 6 times 45, which is 270 tickets. So the range of function is between 0 and 270. Okay? All right, so now let's look at 14. All right, the graph of the cubic function f of x equals x cubed is shown. What is the domain and range of the function? All right, now cubic function is very simple. It's going infinitely to the left, infinitely to the right for domain. So domain for cubic is always from negative infinity to positive infinity. And remember, inequality and set is the same thing. Okay. Now interval notation is, I don't know why my screen is blocked there. All right, there we go. Now, range, it's going infinitely in the negative direction and positive direction, so the range is both negative infinity to positive infinity as well. Yeah, I can't tell you how much that notation bothers me. I just really, the plus sign in front of the parentheses and putting inequalities in infinities, it's mathematically correct, but it just doesn't look. I honestly say interval notation is probably the best way to write it when it's negative infinity, positive infinity. But what do I know? I'm just a lonely old Temple Wildcat math teacher. All right, so end behavior. So as x is approaching positive infinity, it's going to positive infinity because it's going up. Now as x approaches negative infinity, it's going down to negative infinity. Check. Oh, forgot range. Range is Oh, I'm sorry, I didn't see this. How is the range of the function affected if the domain is restricted to -4 to +4? Select the range of the function. Okay, so we would have to plug in -4 and 4 into the function of x cubed. So let's do that now. So f of 4, let's do f of -4, sorry. -4 is parentheses. You always put parentheses, a negative number in parentheses when you're cubing or squaring. Okay, so -4 cubed, and let me just check use my trusty calculator here. Is a -64. Okay, and then f of +4. Well, that's easy. If -4 is, that's +4 is 64. Okay, so we know that it would be between -16 and 16, and it would be between, oh, whoa, no. Wait, hold on. Right, yeah, I'm sorry, range would be between -64 and +64. I apologize for the mistake. Set notation, same thing. And interval notation is bracket because it's included in both. Let's check. Part 3. And let me erase this. That's not erasing, that's scribbling. All right. So select the graph function with the restricted domain. So we know it's between -4 and 4. Hold on. Yep. So looking at A, between -4 and 4 for the domain, and range just looks like about -64, and that looks like a -64. So the answer is A. Check. Check. Those are all correct. All right. Good. Let's move on to the last question, 15. All right. Consider a cable stayed bridge where the height of the bridge deck to the top of the tower where a particular cable is anchored is about, example. Try another. Here we go. All right, consider cable stayed bridge where the height of the bridge deck is the top of the tower where a particular cable is anchored is about 800 feet and the length of the cable is about 900 feet. Select the linear function to graph models of function. So we started 800 and it rates. So we have 2 points. To find the slope, we have 2 points, 0, 800. And 400, 0. Now, a linear function is f of x equals mx plus b. B is the y-intercept, which is 800. And m is the slope. Slope is found by taking 0 minus 800 divided by 400 minus 0. Should be a 0. Okay, so you're left with negative 800 divided by 400, which is negative 2. So the slope is negative 2x. I'd argue, I don't know where they get the 1.94, but that's close to the negative 2, so we'll be okay with that. And so I'm stating the answer is y. Oh, what they're saying is those aren't exactly 0, 800, and that's not exactly 0, 400. But why would you do that? I don't know. Check. All right, part 2, identify the domain range. And let me see here. Domain is between 0 and 400. So they're saying that that's actually 412. Why you would do that, I don't understand. Not just make it 400, but it is what it is, I guess. All right. And so then remember, inequality and set notation is the same thing. So between 0 and 412. Interval notation, it included, so that's bracket 0, bracket 412. Range is from 0 to 800. So there's actually, so 0 to 800. And remember, set notation is the same thing, 0 to 800. Interval notation, it's bracket included, so 0 to 800, check. Apparently there's a part. Nope, that's it. All right, so that concludes the 1.1 tutorial. So I apologize, the video is long, but again, I want to make sure that I cover every question assignment. So if you have any questions on any assignment, I've covered them for you. So with that, hopefully this helps you complete your assignment and have a wonderful Wildcat day.